Okay, welcome to Wednesday or Tuesday's class. Sorry, it's a little early, but I thought I'd try and log on just to avoid problems. So yesterday I started the applications, lesson 2 of quadratic functions, the applications, and that just means word problems. So today I'm going to finish it. Yesterday we talked about a quadratic application question. If you were given the graph, that's always nice because those are pretty straightforward. It's just reading info off the graph. And then we also had two that were given the equation, right? And I recognized right away the equation because it's got a squared symbol in it. Today we're going to continue on. I'm going to do the rest of the examples, I hope. So example 4, we can see that it states that it's quadratic, so we trust that they are not lying to us, right? And that it's a quadratic. But I see that it's not given me equation. The equation is not given. A picture is not given. A graph is not given. There is a picture of the application itself. It says an archway is parabolic in shape. So archways, they're found in this, looks like it's a Greek ruin or something like that. Some doorways are arched like that. Bridge supports are arched. So anytime you get an arch, it's actually a parabolic shape. Some measurements can be taken from the archway, are shown in the table below. Determine the quadratic regression equation. Now, the equation that we are looking for is the equation that models the shape of this structure. You might not think that that's an important thing, but if you were the engineer tasked with building this arch, you would have to have an equation to work off of, right? They don't just randomly start constructing a shape like this. They actually have all the diagrams that the engineers come up with are generated using an equation. So we have to determine the equation. It says determine the quadratic equation. So how do we do that? Well, we enter the data in, right? Like we did last unit with our linear functions. And we actually did a little bit of that before previously in this unit too. So I'm going to, my calculator is, I'm just going to clean it out in case I left something in. Okay, so everything's nice and cleared. All right, so I'm going to enter my data in. Remember where to do that? Stat, edit. And I have 0, 2, 4, 6. And then I move over and I have 0, 8.59, 9.38, 2.34. All right, only four coordinate points. That's not a lot. I usually like to have at least 5, but so now if we take a look at this data, let's take a look at it. Let's turn our stat plot on. Okay, let's just see if we see anything. So again, that was second, the y equals, and you get the stat plot, turn it on, and then press graph and see what we see. So sure enough, we see something. Now, one of the points is kind of hidden. You can barely see it, but it's at 0, 0. 1, 2, 3, 4. So this is definitely not a linear pattern. This is a quadratic pattern. It's making a bit of a U-shaped, right? An upturned U-shape, right? You can see that. Similar to what we saw with the ball being hit or the golf ball being hit in the air and coming down again. So this definitely looks quadratic. So now we have to actually get the equation, right? We'll know we have the equation when we have the curved arc, like a curved line going through it. So let's go back to our steps again. We go to stat, calc. Anytime we want that, the line connecting the dots, it's under stat, calc. Now, in the last unit, we were picking linear all the time. For this unit, once I've determined that it's quadratic, well, the problem told me it was quadratic, right? But if this was an exam question and I didn't know and I had to look at the stat plot first, I would see that parabolic shape and I'm going to choose number 5. This should look familiar to you. I go down to my store reg. I pick my vars, y vars, enter, enter, and then calculate. So this is what's given to me. My data is, it gives me my A, my B, my C values. This is the generic form of a quadratic, y equals ax squared plus bx plus c. And all I have to do again is substitute these three values into the appropriate spots where they tell me. And that's my equation, right? So my equation will be y equals negative 0.98 x squared. Then my b value is going to be 6.25, so plus 6.25x. And my c value, you know what? I'm going to use the whole 4-digit c value because if I round, I'm going to get a 0. So I'm actually going to kind of go against my rule here, 0015. I'm just going to represent it that way, okay? When I'm recording it. I don't have to worry too much because if you look at your y equals, remember when you did that y bars and you store, it said store regression equation, that store reg in that previous screen, it actually entered it in for you. So you're just rounding to put on the pieces of the paper. Your calculator is actually using all the decimals that it can anyway, right? So you don't have to worry so much about that. So here's my equation. And let's take a look now. Now I should see that line going through the data. And sure enough, there it is, right? There's my nice parabola. Now, what are the important things? What's usually the vertex, right? They want to know the maximum value usually. So let's see, sure enough, part B, what's the maximum height of the archway? Because if you think about it, they gave you a table of values, right? If I were to graph this, now they did not ask me for one. But if they wanted, this is my x, right? This is my y. This is the horizontal distance in feet. And this is the height in feet. And my parabola looks like this, right? And they want the maximum height. So they want this value, right? They want the vertex. They want the y coordinate of my vertex. So I'm gonna find my vertex first. Second trace, and it's a maximum value. I'm going to move to the left. Answer yes. I'm going to move to the right. Answer yes. Take a guess. My maximum value is 10. So my vertex is 3.20, 10. Okay, so my vertex is 3.20, 10. And the y value is the maximum height, so we say 10 feet. What is the minimum height? Well, it's ground level, right? So that's going to be 0 feet. And how wide is the archway at ground level? Well, this is 0 feet. This is ground level. So I'm looking for this width, right? From 0 to here, the other x-intercept. Okay, so I have to find this x-intercept, right? And then that would give me the width of the arch at the ground level. So I'm going to put a y2 equals 0 in. Let's move up a little bit more. And now I'm going to do my second trace, number 5. Okay. So if you notice, this is my first x-intercept, right? And I can just prove to you it's at 0, 0. Okay, so that's my first x-intercept. That 2.3 e to the negative 4 means this decimal digit is pushed 4 units to the left. This is just another way of saying 0. If you get e to the negative number, it's a 0. Okay, now let's try the second one, second number 5. This is the one I'm really interested in. Okay, so it intersects at 6.4, 0. So 6.4, this point is 6.4. So that means the width is 6.4 feet wide. And that makes sense, right? Because if you think about it, my vertex was, right? My vertex was 3.2. So the vertex is always halfway between my x-intercept. So 3.2 doubled is 6.4. You probably could have answered that one just using your common sense and your knowledge of parabolas, but it's always nice to get the calculator to confirm your answer. All right, so all the steps were similar to what we've been doing all along. Let's take a look at this last, sorry. This last page. So it's got another. Okay, let's take a look at this one. Clear your calculator. All right, I'm just going to adjust the thing again. All right, so at least we've got some more data this time, right? A ball thrown into the air, the path is generated the following data. Okay, so stat edit. I'm going to just enter all my data in. And enter in my y values. Now it looks like I'm going to turn my stat plot on and take a look at the data. It looks like, whoops, mismatch, dimension mismatch. I think that means I've entered something wrong in with my chart. Let's see, 0 and 1, 0.25 and 9, 0.5, 11, 0.75, 13, 1 and 12, 1.25, oops, 11, 1.5 and 7, and then finally 1.75.5. Okay, for some reason I missed a value. Okay, I'm going to turn my stat plot on. It's on. Let's take a look at this graph. All right, I should see 1, 2, 3, 4, 5, 6, 7, 8, and I don't. I can see that my X-min and X-max is only 1.75, so I think I'm going to reduce my X-max to like, I don't know, 4 even. And I could reduce this to 0, right? And let's see, my Y max 0 is fine for a min, but my max has to be a little higher. So I think I'm going to use it 15. So I put in 0 to 4, and that's lots of room. And I put 0 to 15, and my high value is 13. So that should make my graph look a little easier to read. And when you make your graph a little easier to read, you can see that you get that nice quadratic pattern, right? That nice quadratic forming. Okay, it doesn't look like it's starting right at 0, 0. So let's see if we can get this equation. So once again, I'm going to stat calc. It's going to be number 5. And then I'm going to store my equation. This is going to store it into the y equals screen, right? Vars, y vars. And this is putting it into the y equals screen. Okay, so here's my equation. I have my A value, my B value, my C value. I have to put those into the appropriate spots. So y equals negative 15.67 x squared plus 26.73x plus 1.81. That's my equation. Not only do I have my equation, but it's in my y equals screen, which means it's going to show up as the curve going through my data, which is great. What is the maximum height the ball reaches, and when does it reach this height? Okay, well, we have to find the vertex, right? That's the maximum value. Okay, I got to move it to the left, move it to the right. Take a guess. So my vertex occurs at 0.85, 13.21. So that means this is my time, this is my height. So it says it means the maximum height is 13.21 meters. And this occurring at 0.85 seconds. Remember your x coordinate, I move back up here. Your x coordinate is the time, your y coordinate is the height. X coordinate time, y coordinate height. How high will the ball be after 0.6 seconds? Okay, well, I'm looking for a y value. So that's, I know my x value, so that's second trace value. And I put in x equals 0.6, and that will give me my y value. Okay, second trace value, 0.6. And then that means the height will be 12.21 meters. Okay. And I have to say the ball will be 12.21 meters. Okay. How long does it take until the ball hits the ground? All right, we know where that is, right? If I think about this just quickly in my mind, if I have time here in seconds, and this parabola doesn't start at the corner, right? But it goes like this. So I'm looking for this. I'm looking for when the ball hits the ground, when the ball's at 0 meters. So I'm looking for an x-intercept again, right? So how do I do that? Second trace. And this time, I have to put my y2 as 0, right? So it's number 5, intersect. And then I do my 3 questions, right? All right, so I'm going to put a y2 statement in. y2 is 0. That gives me a second line for an intersection point. Second trace, number 5. All right, it's hard to see where the cursor is, right? But if I look here, this is telling me if I keep moving, I'm getting lower and lower into the negative territory. I don't want that, so I'm going to bring my cursor back. And if you keep kind of moving up, there's your cursor, right? So move it down. And then answer your 3 questions. So here, when y is 0, x is 1.77. So that means this is my second x-intercept. So it takes 1.77 seconds to hit the ground. How long does it take before the ball reaches 5 meters for the first time? All right, well, remember how high the maximum the ball reaches is 13.21, right? 13 point something. So we're asking, when does it reach 5? So I don't know when. What do I have to do? I'm going to enter in. So I want to know where it reaches 5. So I'm going to y2 is 5. And then I'm going to do second trace number 5 intersect. Again. So I'm going to go to my y2 screen. I don't need the intersection when y is 0 meters. I need it. I want to know when y is 5 meters. Okay, so second trace number 5. Here's my curve. And there's my y. Now notice it meets 5 twice. So it says the first time. So this is the intersection point I want. So second, whoops. Sorry, I have to move my cursor. I don't want this intersection point. I want the first one. Just like you have two x-intercepts, you have two intercepts where the graphs coincide at 5. Answer your 3 questions. So point 13, comma 5. Right, so then I'm just going to kind of do my, this is 5, and this is the intersection point we want. Okay, so x equals 0.13. It takes 0.13 seconds to reach a height of 5 meters for the first time. Okay. All right, I think that was a lot. I'm going to stop it there, and I'm going to assign. We've got one more example to do. It's just, we've done a question like this in linear, but it's a lot to take on, I think, at the end of this class. So I'm going to assign, I'm going to get you to work on numbers if you want to start working on assignment 2, 1 to 5, but it will be a work class tomorrow as well. So try assignment 2, number 1 to 5. Okay, and then that will be it. Please contact me for questions or to do some homework. You can just request homework questions and I can do them for you too. Okay, so I'll see you or I'll talk to you tomorrow.